going to announce our next speaker, which is Irina. Irina is a Microsoft MVP within the development technologies area. She's also a software architect and a Microsoft certified trainer. She is going to talk today about gRPC. Welcome, Irina.
Hello, everyone. Thank you for having me. I hope that after my talk, you'll know more about gRPC and the usage of in a proper scenario, in a proper real-world scenario. I'm gonna share my screen now. We cannot do anything without a few slides. We're gonna have a look at code, a lot of code actually, later in the talk. So a little bit about me. My name is Irina Scurtu. I'm from Romania. I'm a software architect at a company called Endava. I teach .NET, and I also blog from time to time, not often, not as often as I would like. But I always promise to take my revenge on that and publish all the drafts I have. I have around 15 or something like that. 50, sorry. Okay, so we cannot talk about a distributed world without remembering the monolith. And I have a confession to make. When I was a young junior programming 11 or 12 years ago, I had apps that I've been working on that were monoliths. And I remember one of them was so big that when you wanted to build that application, you simply should have pressed build and go away and grab a coffee. It was an easy life for a developer, for a junior developer, because pretty much everything was in there. Whenever you needed a class, it was there for you to instantiate or use the dependency injection mechanism, if you were lucky enough to have one. But you had only one big block of code. In case of the deployment, that block of code was simply taken and shoved it into production, right? But there is a bad fact about monoliths. It's easy to understand, first of all, and that's a good side. But in case something doesn't work as expected, it's all or nothing. So when you deploy, it's all or nothing. It either works or it doesn't work. When you have microservices, let's say that you're saved because you have pieces that might work and pieces that don't work, but it's not all or nothing, right? So with the monoliths, for me at least, the life was easy. It was very easy to onboard the new developer on the project because you simply, everything was self-contained in there. I'm a .NET developer and passionate about everything .NET. And well, I remember that it was very easy. I worked on ASP, MVC, or web forms, and everything was in there. The big chunk of app was there for me to use and to understand. I didn't have moving parts like we have now when we struggle and when we go straight away to implement microservices, even if microservices as a concept is not needed for every architecture and for every business out there. But it's just the way we do things. Microservices everywhere and the new shiny thing. So pretty much everything was kind of like this. You had a database or several databases, and everything was front end plus back end in a single chunk, in a single block. But then a few years later, well, things started to be split. Because I don't know, it was mainstream, that's the way the things were done. Now we have front ends and we have back ends. We have APIs that communicate with the database. And if we're talking about microservices, these should be self-contained API and databases and should be only one database and so on. It's a whole theory behind it. But we all know and we all have to accept that the future is distributed. Simply if we think at the fact that, well, the quantity of data is getting bigger and bigger. We need to process a lot of data. We need to respond as fast as we can, even in real time or near real time. And then we have no other option than to go distributed. And now we have front ends that aggregate different backends. And those different backends end up communicated with several databases or even with other backends. It's service-to-service communication. And now we do not have only one technology because we try to pick and choose the right technology for the job and the proper tool and language, right? So we might have .NET Core that communicates with something that is written in Go. And that Go app might communicate with a Node.js, and so on and so forth. And that Node.js app might communicate with a third-party API that you do not know in what language or platform or framework is written in. So that's the way the world goes, right? And we need to adapt. We need to learn and to overcome the burden that appear in production. But you might say, okay, this is a talk about gRPC. Why we're talking about this? Because we kind of have REST for everything. We all do. When doing microservices, we all say that we implement REST APIs. Admit it, I also did this. REST seems to be as de facto standard for API implementation. So when we say API, in a way, REST is self-explanatory. We say API, we automatically say REST. Even if we look at those APIs and we realize that those are not fully REST, but that's not about it. So now we have a client and we have a server, and these two communicate with each other. And when it's about APIs, there's the process involved that we kind of do not care, but it's happening every time when we issue a request. That is called content negotiation. That content negotiation is about the format of the request, what is contained in the payload, how do you handle errors if they are retries, how do you handle authentication, and what happens if the model changes, the model of the request or the expected response. So these are things that we should care about whenever we have APIs in our apps. So we're so used to this REST or HTTP, JSON over HTTP approach that we take it for granted. We do not care what happens when the model changes, and we kind of do not care how to have a retry policy, right? So there are cases when REST or traditional JSON over HTTP is not enough anymore. Maybe you want something more or something else, right? So you might want to look at the different technology. And you might say, okay, what's wrong with REST? It works. We use REST to do service-to-service communication. At first, when you start to do microservices, that's the go-to option that at least what I've seen at a lot of developer teams. They do not introduce messaging and queues and message brokers in their architecture. They do HTTP client requests between microservices to get data from one side to another. And it works, kind of works. It has a lot of problems, but it works as the first step in a microservice world. But what happens when you have this kind of APIs and this kind of service-to-service communication is that there is a lot of team communication involved. You need, for example, to talk with the team that develops the API to say, as a front-end developer, hey, dude or girl, give me back another field, or give me that field and that field, because the UI changed and I need to add 2 extra fields in the UI. And then there are other options when in the front end, those 2 or 3 fields are not needed, but are still sent from the server side. And you need to tackle that. There is a constant communication between the teams or between developers to make sure that what's expected, it's received, right? So it's not that I'm not encouraging communication, but that time that is spent on doing that, if you do not have the proper tools or the team is very big, can be well spent somewhere else in other parts. So now I want you to introduce or to talk a bit about RPC, or remote procedure calls. So RPC as a concept, it's been there for a lot of time. from the 60s, I think. RPC, if we look at here, it will look something that is not from the same machine, look local. So for example, I have here a few lines of code that I would like to look at. And hopefully you will see how I highlight with this red stuff, because it happened to me and on Teams is not transmitted. So I have a variable that is called order, and it's from a sales bounded context. It's a method call that creates order from an order request. Below it, I have a payment status that tries to process order for that payment for that order. And then what I'm doing is I'm checking that if the payment status is successful, I'm gonna arrange the shipping for. Everything is looking like is belonging to the same project, right? It's from there. It's from the same project, from the same app. It's very code oriented, right? If you look at every line of code, you kind of can't tell if there is a network call involved. It's just a method call, but a network call over the network, it doesn't look like it, right? That's the purpose of RPC. It's a more programmatic approach to make the network transparent. It's like there is no network involved. So if we look further at this one line of code, we'll see that payment status and the process payment for that order, it's a method call. That's it, right? So in fact, what if I would tell you that a call over the network is made, and a call over the network is made for absolutely every line of code in there. So RPC as a concept will make the code look local. It will be a kind of very easy for a junior developer to onboard because the IntelliSense in Visual Studio will work and everything is there. But there is the but for this because it's very prone to errors. When everything is available to you as a developer in a programmatic way, you ignore things. You ignore that calling a method will imply a network call, DNS result, and so on and so forth. So it's prone to errors. The goal of RPC is to allow a developer to have an easy life without taking care of everything that's network related. Imagine if you have an HTTP client, that HTTP client needs to be instantiated, and you'll do a request, post, get, a put, or whatever. You'll do a request. But when you have a method, you just call that method, use that method, and that's it, right? More than that, RPC, not gRPC, the RPC will make a distributed system behave like a monolith because it will look like it's self-contained. And of course, it will make network communication transparent. Okay, RPC has history, enough with that. But gRPC, it's first born in 2001 as a Google Stubby project. And then in 2005, gRPC has been open sourced. And a few years later, September 2019, gRPC was shipped with .NET Core. And it was a major paradigm shift for us as .NET developers. What is gRPC? gRPC, first of all, is contract-based. You will have absolutely no code references when it comes to what you have available and what you expose. Underneath the scenes, it will use HTTP2, which is inherently faster. And when it comes to serialization, it will use protobuf, that is, it will end up with a smaller payload. And with, of course, the request over that, it will be way faster, inherently faster, even for the serialization part. And more than that, it's available in many languages. And with .NET, it will have code generation out of the box for you. Now, what is gRPC and how it behaves? It's allowing you to have a definition of the service. We'll have a look at that. And you can take the definition of the service and share it with our other projects, but you'll have no code references, as in right-click, add reference, search the package, and so on. So gRPC introduces this awesome special file between your client and the server, or the API and another API, and becomes the common part. So there will be no reference involved, it's just this file. And the proto file, we need to talk about this. It contains a special syntax. It has a lot of documentation. It's like C# with specification language. And it has a lot of specificity to it, so you really have need to have a look at that. So the first part is to declare, hey, I'm using the Proto 3 version, the syntax. Then in the option part, I'm declaring that the namespace for this project is my first gRPC. And then the package that is generated for me is Fibonacci, for example. So what you will do in a specific proto file is to define the services that you're exposing. So, and you will start exposing this by using the RPC keyword, the name of that method that you want to expose. The requested number in this case is the input parameter, and the returns is the type that you return. So it's like a declaration, right? It's like we have an interface, more or less, but with specific syntax that tells, okay, this is what I have available for you. The requested number and the Fibonacci result are nothing else, nothing more than types that you need to also declare in this proto file. And you start with the keyword message. You give this message a name. And then inside, you specify the properties, the fields that you want to contain there. Bear in mind that the number equals 1 is not an assignment. It's an actually order of the field in that specific chunk. For example, if we would have 3 properties, you will have equal 2, equal 3, and so on, because being binary, it needs to find out the position for that specific property. So nothing fancy so far, but something that is very fancy in my opinion is that gRPC has a few 4 types or modes or method types. It depends on where you look. You'll have a different terminology, but in fact is the same thing. So you'll have the unary option, which is simply a request response that we know from HTTP, normal HTTP. You will have server streaming, where the server is sending a lot of data and it will receive a simple answer back. Client streaming, which is the reverse. Client sends a lot of data and server will respond with only one thing. And bi-directional streaming is the previous 2 combined, which means that the client sends a lot of data and receives back a lot of data. So it's like you have chained a lot of responses and a lot of requests, but in the same context, in the same request. So unary, you'll see here, I hope, a small representation, dummy data. Unary is what we know. There is a client that issues a request, that request goes to the server and is processed, and then an answer comes back to the client. Request response as we know it. In gRPC context, we call it unary. Okay, how it looks if we were to define such a unary operation in a proto file. So you'll have RPC, your name for that method that you want to expose, the type and returns, and then you have Fibonacci result. The second option is server streaming. Server streaming means that the client issues a request, just one, and the server inside a response has a lot of data or a lot of small responses. So it's one in, several back. It should be the translation of it, the server streaming. And the client streaming is the reverse. The client sends a lot of small pieces and the server responds with one thing. Okay, so this, think about it. how cool is this to uploading files? If you chunk files and you set those chunks, right? And server then responds, okay, I received everything. It's cool. And the last type or method is bidirectional, where the client sends a lot of things in as a request and the server responds with a lot of things out, right? The difference is in terminology or in syntax, when you declare such service, is the keyword that is highlighted with yellow, stream. Depending on where you put that, it will mean that if it's in the parameter part, the client will stream. If it's in the response, then the server will stream. So the entity that responds with the stream, right? So let's see. In comparison, why REST and why RPC? So REST is resource focused. We know that in REST we are working with resources, but in RPC and gRPC inherently we're working with action. Everything is action-based. We are calling methods. We do not have resources. And REST embraces HTTP semantics, whilst RPC and gRPC embrace programming semantics. You call methods, right? When it comes to coupling in both of the approaches, in REST, we tend to see that we have loose coupling. And that depends. In REST loose coupling, if you decouple the client and the server, then yeah, you have loose coupling. But if we're talking about client to server communication, then you do not have loose coupling because you kind of depend on the both services being up, right? In RPC, you have a thing that is common and shared amongst all the services, and you have a tighter coupling. REST is text-based, and RPC is binary-based, right? So now, if we were to look at this, we have a .NET Core server, and we'll have clients, and those clients will be server apps, or console apps, or whatever apps that share a common thing, that gRPC stub. So now, there's that time to look at some code. So let's see. First of all, I'm going to start by creating a new project. And you'll see that in Visual Studio, there is such a project already there. So create a new project. From the list of template, you'll find the gRPC template. So it will be gRPC service. And you click next. You give it a name. And in here, you have the option to select the .NET Core you want. I'm going to go with 3.1. I'm going to click Create. And what you will obtain, it's something that will be very familiar to you, minus a few folders. So if we were to look at this, you will, what happened? Okay, so I'm gonna try and zoom this a bit. You'll see that we have the startup CS, program CS, because we cannot get rid of those. Those are very important. Appsetting.json, but everything else is missing. You do not have controller folders, models, or whatever else. You have, in fact, the protos and the services. And each of these folders will contain a dummy service and a dummy proto file. And you'll see the grid proto is the standard one that comes with the template and is just a start, okay? So you have the syntax, you have the C# namespace that you give and usually takes after the project name that you give. The package that is taken from here. And what it happens, well, you define RPC, it's called say hello, as the parameter receives a hello request and returns a hello reply. And here you have no other, you cannot have like void, you have to have a type as an input for each method. Okay, and the two types that you define in there. If you have something like this, for example, you want another string, I don't know, last name, you'll have the order 2. But again, this doesn't mean assignment. It's just order in that small binary file. Okay. If we were to look in the services, you'll see that this service does nothing else than to override, so basically give an implementation to what is exposed in the proto file. What it does, it has the same name, hello. It receives a hello request. And also, a thing that you cannot get rid of is the server call context. The context is the context of the request and the response, something that is similar with HTTP requests that we know of from the classical ASP.NET. You do your logic here, and then you return something that is also specified in the interface definition language. So this is what you implement, the actual thing that does things, right? But the service, each service that you will need to implement, will inherit something that is auto-generated. And if we were to look at this, you'll see that is grid gRPC.cs that is generated on build. Okay. Things with strange abstract partial classes and so on. And it adds a method that is called say hello. It's done automatically by you. So when you add the proto file, you won't need to generate this. You do not care about this. It's there for you to use. Okay, so the proto file, this small chunk, it can be taken and shared, because I will show you in the second project that I have no code references between different apps. I have only the proto file that sits one level up. What you need, also, if you want to start from scratch and you want to add gRPC, you will need some packages. Apparently, this is already there. But I'm going to show you because I started from scratch in console app. So this is gRPC ASP.NET Core, but you also need a few other things. Okay, so I'm going to close this and I'm going to show you the 4 ways, right? So first of all, I'm going to start with the server. This is a project that will return data. It has basically the services implemented that I'm going to call from different apps. So I'm going to show you here the protos. I kept the same name, greet, but in here I have defined all 4 types. So proto 3 package is called greet, service is called greeter, and I have the 4 types. This is the unary because it has an input and returns an output. Server stream, it receives something and returns a stream, this stream keyword that I told you that is very important. I have the client stream that the client receives one and returns one thing, right? And bi-directional, it has both streams. It receives the stream of hello request and returns a stream of hello reply. This is the same approach: hello request, hello reply, message, and name. And what I did here is to implement the service for each of the things that I have specified in the proto file. Okay, so greeter service, here is greeter base. You can use this service and you can inject everything that you are used to. You can inject repositories, other services. It allows dependency injection. As you see, I added a logger in here. And along the way, I have logic for absolutely each and every method type. Okay, so for say hello, the unary one, I receive a request and I return a hello and the request name. Okay, this is the logic. But now, if I go to the first one, the unary, you'll see that I have simply a console app with nothing special in it. I have the program CS. And if I'm gonna look in the dependency part, you will see no reference to the previous project that actually contains the logic. So the codependencies and NuGet package sharing is absolutely removed. But what you will need is Google Protobuf, gRPC, and gRPC tools. These are the three packages that you'll need whenever you want to add gRPC in an existing project that is not the standard template. Okay? What you need to do, and what I want to show you is if I look and edit the project file, you'll see a few things. So you see a few things that are related to the Nugget packages, Google Protocol Prof, gRPC, and gRPC tools. And another thing is an item group that has an include with a path. That path is, if I'm referring to this specific project, I'm starting from the unary, I go one level up and in the protos folder, and then I have the grid proto. And I'm going to show you. I'm opening the proto file from the server, open folder in File Explorer. And you see this is a single and sad file because it's single. So it's up one level, protos file. This is in the services. Okay, so what I'm doing is referencing this file that can be somewhere in a specific location that you're gonna make sure that it will be discoverable by your projects. It can be shared by your CI/CDs on deployment, but you need to make sure that this is there in order to allow other projects to discover this. Okay, so this is the common things with Proto, but no other code shares. And if we're looking at the actual code, how you call the gRPC service is something that is very similar to HTTP client requests. But in this case, you'll have something that is called a channel. You do not have an HTTP request or the notion of request anymore. You have channels that need to be opened in order for you to call the methods you need. Okay? So we need to create a channel. You have options. This is the server location. You can secure if you want the gRPC channel, but you can also specify that it's insecure, you'll get, and that's it. And then you will need to create a client, and that client will be needed to pass the channel in. So the client, as you see, I do not have anything shared in there. If I write this client, greet client, so it's greeter client, is there for me. I didn't wrote that, so it's there for me to use. It's automatically generated. What you need also to do is to have the input, the parameter that you want to send, and well, send the request. And by sending the request, I'm referring to the actually invoking the method that you want. So that method will be available on the client. As you see, I have the say hello async because it will also generate for a few methods the async version for now. Client stream, bi-directional, and server stream. Okay, so all my four methods are there for me to use. So I'm passing the parameter, and also you have the option of passing this object, which is call options. And the call options, it's a lot of things because you can pass something that is called headers that will mimic the actual header from the traditional HTTP requests, but here it's called trails. You can pass a deadline. For example, if you do not get the answer back in 30 seconds, you can time out that call and stop the execution. A cancellation token you can have there, propagations, credentials, and kind of that's it, that it actually matters. But you have the option of passing this object to tweak your method call. Okay, enough with the talk for this. I'm gonna open a console, and in the left-hand side, you'll see the server that if I'm running, it will simply have a port open and accept requests. It will run on 500 and 1 and so on. And on the right-hand side, you will have the unary call, which is another client app, the console app that I just showed you, that will issue requests. And what it will do, it will send netdd, and it will receive hello, what I sent, netdd, right? And on the left-hand side, you'll see that through the diagnostics that it's an HTTP2 request, a post request actually, done at this address, which is localhost 5000, and there is not an API / something anymore. It's the actual method that we invoked. So we have greeter.greeter, and from that greeter.greeter is the say hello method. The MIME type for that is now application gRPC, is not application JSON or what text or HTML or whatever, but it's application gRPC. 200 as a status code, and you also see how long it took. Okay, so it's the mimic of the traditional request response, one in, one out. Okay, and now we won't close the server, but I'm gonna close this unary one, and I'm gonna show you the other one, the client streaming, which the server will wait. And I'm gonna run this, and I'm gonna show you the code in a few. You see, the server receives things. Receives, because the client streams now, sends a lot of data. And I think I went through with in a loop with an I that starts from 0 to 10,000 or something like that. You see, now it's finished. This is the last I that I've sent. And the same, we have the diagnostics. We have the method that was called greeter client stream. We have how long it took, right? And the client that streamed those requests had only one thing back. And one thing back is the last I that it received. So it got back, okay, I got this number, okay? So you see, there is no signaler or whatever involved. The client simply streams in the context of the same request, which is very nice. And now let's have a look at the code. It's the same principle. We have the same proto file, and we have a class console library. So client streaming, let's see. So the client streaming is very similar. We have a channel that we need to open, and then we create a client and we pass that channel in. And then we have something that might look very strange to you, but what we're gonna see. We can also have the same options in there. You can have a cancellation token source with a time span if you want, in order to finish everything. And what happens is that we're calling the client stream method that we exposed in the proto file, and in the for loop that starts from 0, less than 100,000, we're gonna write in the request stream, So you're gonna push things to send, like sending a lot of envelopes, one after one, okay? So what you do is, and the call in the client stream, you say, hey, open the request stream, so open the highway towards the server and put a lot of things in there, one after the other. Put this I that goes to this. For how long? Until it reaches the end, right? And with every I that you increase, you're sending hello request and that I made string. It's a dumb example, but I wanted to keep it that way to be easier to understand, because I must admit at first it wasn't that easy for me. Okay, I'm writing in the request, huh? It's not that easy to grasp. Okay, so you have a highway and you put a lot of things there. It's like a tool belt or something where you put a lot of products. Okay, and what you do, you await to be completed. You have the request streams, complete the sync, okay? And the response will be just only one. You'll await that. And at the end, what I do is, okay, receive that one response. Another thing that I want to show you here is that you do not have status codes as in the traditional way. You can catch RPC exceptions, and I'm going to show you in the next example. You have RPC exception, and you also can use the C# pattern matching to say when this happens, and so on and so forth. You have status codes, but these status codes are not traditional, like 500, 200, 300, and so on. There are something specific to gRPC. Okay, aborted, already exists, cancel, data loss, deadline exceeded. If you send the deadline as an option when you do the call, you might receive this exception. When deadline exceeded, do that. Precondition, internal, not found, okay. Apparently, okay has a 0 as a status, not 200 as we know. Out of range, permission denied, and so on and so forth. So there are less than the 63 of status codes that we have in HTTP, the classical one. Okay. But you can also catch RPC exception because it's just one, but you can treat it differently by using this approach. Okay. Client streaming. Server streaming. Let's see what's happening when the server sends things back. Okay, I'm going to show you the example again. The server is there, awaits requests. And now, instead of client streaming, I hope this finished. I'm going to close it. Server streaming is the same. A console app that does the thing with an eye. I'm going to run the app. You see, I'm getting things from the server. Things, hello, and this value. But in the server part, I got one request in a way, right? So the server receives a request kinda and sends a lot of things back as response. Server stream is the method that we called. It's still application gRPC. It took that much, but back we got these values. Okay, so maybe, I don't know, I don't think these are proper namings because are kind of confusing, but the server sends things back as responses, several responses. And if we were to look at the code, it's the same concept. You have a channel, you have a client that you open, and then you need to create a streaming call. You call the method that it's corresponding to the server stream. You create one request. You see, there is not a for loop in there to create several requests. It's one request. It's like opening the chat line with the server, and you wait for it to be done, and then you await all the replies that comes from the server. So how you do that? You have a for each. You get the hello reply, and what you do is read from the response. If in the previous example you were writing to the request, right? Now you're reading from the response tree. So this is the way you do it. You open the streaming call, you have the response stream, and you read all async. And pretty much this is it. This is everything that happens. But another thing that I told you is that you do not have headers as in traditional way, what you have with HTTP headers. You have the concept of trailers. And that trailers is nothing more than a dictionary where you can add keys and values to it. With it, you can mimic headers. Maybe you want to send something additional than the request response actual body, and you send this pairs, okay? So this is how you do things with it. Also, I'm gonna comment this and uncomment another call where I'm passing a hello request, so one request, but now I add the deadline, and I added the deadline for 1 millisecond. And now when I run again, the server streaming, I'm gonna clear this to show you from the top. And server on the left-hand side, I'm gonna run it. What? I think it didn't compile. Let's see if I saved. I didn't save. Okay. Take 2. You see, now it's timed out. It timed out because I added a deadline of 1 millisecond. So if nothing came back in 1 millisecond, then the request wasn't processed. because I specified this when making the actual call. Okay, and the last thing that I want to show you is the bidirectional. Okay, same. The server in the left-hand side awaits for incoming requests or calls, and on the right-hand side, I have a console app that will send something and it will receive something. So is the bidirectional call. And in here, I'm sending the same I, but until 10. So I'm sending 10 I's and I receive back 10. Okay. And in terms of code, it's a combination of the two. It's the same channel, best in the client. And then I'm using the calling bidirectional. And as long as I write something in the response stream and I get something back, I can call this here. Again, for the request, I'm issuing a request and I write in the request stream. It's a bit the other way around because you kind of write in the request here and you receive at first here. Okay. And another thing that it's worth mentioning is this current. This current, it represents the current call, the current context. And in here, you might have some other options. You have messages, you can write to the current things, you can see the size and so on. You can merge a lot of things, fix exactly in the current part. Okay, we looked at the calling parties, but we never looked at the actual implementation of the methods that we're calling. And I think it's worth looking at. So in the greeter service, when I have the four things in here, say hello is simple. One thing in, one response out. But for the server stream, for example, the actual logic that is happening. So you have one request and you expect the server to write many things to you back. And you'll have the iServer stream writer as the hello reply. And again, you'll have the third parameter in here because the server call context needs to be there and you won't be able to actually give an implementation for that specific service method if you won't have this. It will be automatically generated for you. It gives you access to, I'm going to write here, context, authorization context. So in the context, like in HTTP request, as we know it, you can find things related to authorization, things that were used when making the calls towards it. And also you can obtain the HTTP context. Host, the method, peer, request headers, trailers, the status, but the status is the one for the RPC, not HTTP. User state, a lot of things that you can override to customize the way you are writing to the response. There are things that worth, if you really have the case, that's worth exploring. So you will find in the context. So in the server stream, once the server will receive this request, it iterates through to that actual number and it sends back a message. And that message is written in the response stream. So that's all logic that is happening in there. And also what I added in here is to tweak a bit with the header, with the trailers that I mentioned. The header, the mimic of the header is done by using this type metadata entry. It's simply just the key value stuff. So if you want to add things as headers, you can do it in this specific manner. You can have entry, you can give it a type, and you can have a value for it. And also you can stick these headers in the context. So in the context of request, the context call, you have the context response trailer, and then you add what you created in there. That's the whole logic. Okay, in the client stream, it's pretty much similar, with the small exception that now we're receiving an async stream reader of hello requests. So a stream of requests, and you have the same server call context in there. And in terms of logic, you get the hello reply. And how is this translated is, as long as you have something in, you need to move next and wait for the next. And you need to extract the payload. And the payload is simply extracted from the request stream by using the .current property. Okay, what I'm doing is writing the payload and then composing a message to answer with. Okay. I don't know if it makes sense. I try to keep it very simple. I don't know if I managed. And the last example is the bidirectional one. So the bidirectional one will have a stream of requests and a stream of replies, and the third parameter, which is the current context. What happens is he'll wait the request and then respond. Okay, so as long as I have something in, I can give something out. This is pretty much the simple translation. I think it's very powerful to have also bidirectional, and also the client stream has a lot of good use cases. It can simplify a lot of things. And I know it might be a bit difficult because we all used to with, well, HTTP and so on. And now you have no HTTP, but you have a call that behind the scenes is doing an HTTP call. It's somehow confusing. But why gRPC, and why I'm trying to preach a bit about gRPC? Because of the performance. It's one thing. Because it has the HTTP2 behind the scenes, and it also has the nice serialization in binary, you'll end up with a smaller payload. And I have here one example. In REST, a response will be that amount of bytes, and with gRPC, the same example will be that amount of bytes. And if we do a percent, it's like 80.98% smaller, which is cool. And if you care about the bandwidth and the data transferred between your servers and the clients, it's very important to also look at this. gRPC will allow polyglot environments because it has code generation in a lot of languages, not only in .NET. In .NET, it came very, very late, but we have C++, Go, and many others that we can use simply by using the same stub. So it's powerful. So it's lightweight. It's super, super good for point-to-point communication. If you have something to carry over from here to there, it's super useful because it's performant and it's straightforward. But you need to keep in mind that it's network involved in there. And you also need to take care of network transferring, and you need to take care of retry policies. And you need to take care that the both system to be up is that temporal coupling that it's still available. So contract-based, smaller payload, HTTP2, and supports different streaming types without using some additional technology like SignalR or I don't know else. I think it's very powerful only because of that. But no technology has no downsides. So we have to talk about downsides. And one of them, and the biggest, I think, it's the temporal coupling. So if in microservices you're doing service to service with HTTP clients, and in order to get data from the second service, you need the second service to be up. So that's here. By using gRPC, you won't remove the temporal coupling. You'll need the both system to be up in order to get data from the part that you're calling. Another downside that I think is that you might forget that there's the network involved. It's so easy to, you see, yeah, I'm creating a channel, I'm creating a client, I'm calling a method. That's it. But it's not that obvious that there is a network there. And you might abuse this power. You might do a lot of calls to get the same data over and over. Because, for example, in HTTP, you might be aware that, hey, if I'm making 2 calls to get the same data, maybe there is a way for me to cache that data and not call the second time to get it back because I already have it. Another drawback is that it's not human readable. So you cannot do like use Postman and to see the actual response. You have binary and you kind of do not know how to read binary yet. What you need is better testing. But that better testing will also imply that you need to focus on CI/CD. If you have gRPC and you won't have code references anymore, when you have all the systems in your CI/CD and you build the system, now you won't have that, hey, I'm missing that reference, the build won't pass. That won't be the case anymore because the common thing is that protofile, and you will need to make sure that you are sharing that protofile and that's available there. And it's up to you to do that, and you need to take care of it. So in summary, it's super nice for microservice communication or point-to-point communication. It allows you polyglot environments, it decouples code, and it had those 4 methods out of the box by using HTTP2. I think, if you ask me, that the future of web APIs is distributed. There will be no more hunting for documentation, and there will be no misinterpretation of HTTP codes anymore. And there will be no more data parse errors because now if the protofile is modified, all the services, all the projects that are using the protofiles will have the same version. If you add something extra in terms of fields in the message, then every project that uses that protofile will have that extra field. So no more mismatch, no more missing data because you forgot to add in a microservice another field or things like that. And keep in mind that distributed systems are all about trade-offs, and there is no technology to solve every problems. Just bear in mind that you need to pick the right tool for the job. Okay. So next steps that I want to recommend is to look at gRPC web. Now you can do calls from browser to something that is gRPC. HTTP2 as a protocol, and know that HTTP3 is also in progress right now. And I think protocol buffers, of course, we cannot ignore this. And I think that I recently noticed is gRPC curl is written in Go. Antoni Giretti found out this. It gives you the ability to curl endpoints, gRPC endpoints, which is very cool. So thanks for listening. I hope you know more about gRPC now, and my example were useful. I'm here to answer questions.
Yes, Irina. So thank you. You had a lot of compliments about the hands-on way that you gave your session. A lot of people were really happy with you just digging into the code and describing the problem, and then a couple of ways to solve it. That's awesome. So we do have a couple of questions. Actually, Patrick was on a question streak, but at the end of your session, you happened to answer a lot of them. But there are still a couple of questions open. One is for Xeps, and I really don't know if I pronounced that name correctly. But Xeps says, what is the option? Will gRPC shine? Yeah, where should you or should you not use gRPC compared to REST or ordinary web services?
When should we use gRPC? Well, the answer that any architect will give is that it depends. No, I'm joking. But you also need to add some argumentation for it. So we need to admit that REST is used in a bad manner in many projects. REST shouldn't be there in all of our APIs. And we should look at using a message broker in specific microservices. But if we're talking about gRPC, I think a lot of APIs that are using REST should be gRPC, in fact, because they're not using the REST principles and they're using more, I don't know, they are more JSON over HTTP and that's it, not actually following the REST principle. REST is good for public-facing APIs. gRPC shines when it comes to service-to-service communication, like internal inside your system. But if you want to expose something to a front end, then you want to use REST because it's easier to understand even by front-end developers.
Totally makes sense. And I've got one good question by Johan Benschop. He asks, how about versioning and backwards compatibility with gRPC? So I imagine that he means, for example, when we're creating a web API, you can include versioning in the routing that you use, or use headers for that to be able to redirect certain requests to an older version or to the new version of your API implementation. Is there a way to do that with gRPC?
Yes, there is, by marking fields. For this, you need to look at the protobuf syntax. Mm-hmm. And I didn't dig too deep into it, but basically versioning is either you add fields, either you remove fields. And if you remove fields, you need to leave those fields alone and mark them as deprecated. And if you add extra fields, for example, in the message, then it will be no problem. Every service that shares that proto file will see that new file. You can create different versions, for example. You can override, you can inherit the services that implement. But I think versioning is a bit harder than in REST, in gRPC.
Right. Understood. And I think last question is by Roland Koops. His question is gRPC supported by Blazor WebAssembly?
You can definitely, with Blazor WebAssembly. I don't know what to talk stupid things right now, but you have a .NET and you have Blazor that is .NET. Mm-hmm. So I'm sure it works. I know it works with a lot of different types of projects. It will work with Blazor WebAssembly because you are not writing in assembly, writing in C# and use the thing that's called gRPC. So for sure, I think it works.
And then just to run through Patrick's questions, but I believe you already answered them in your question. You say, he asks, so async await is built in, but abstracted away, and the retries, should you think of retry? And in my opinion, you already answered that is one thing that you have to implement as a developer, right?
Yeah, you need to take care of that, because if you're calling a method from a gRPC method, and that party that you're calling is not up, well, you need to retry that. So
you're
it's
going
up
to have problems.
Yep.
And then there's this comparison between calling a service from a web browser, but obviously you just said that from your web browser you should use a REST service and not gRPC, right? From a web client, is that correct?
Yeah, but there are initiatives, and I think it's gRPC web is already there. You can look it up on GitHub. It will allow you to call a gRPC service directly from the browser.
Oh, that's awesome.
So it depends on the scenario you have.
Yeah, but I think you'll run into problems with the binary serialization.
You might.
Yeah, all right.
You might.
So, and then a couple of questions from my perspective. First of all, you're from Romania.
Yeah.
How is the COVID situation in Romania?
The number of cases are decreasing, which is a nice thing. Mm-hmm. They started the vaccination, but we have a lot of restrictions, like a curfew. And tonight, after 23 o'clock, you cannot travel and be on the street.
Yeah, we're facing such a rule as well. As of tomorrow. But then as of 9 o'clock, you cannot go on the streets anymore. And I was curious, you're a certified Microsoft trainer.
Yeah.
How do you deal with that with COVID? Is everything virtual or something, or are all the trainings stopped for this moment?
No, everything is virtual. I also teach .NET for people that want to switch into IT from different domains, like for economics and so on. And we did the classes online, and it works very fine. Personally, I missed face-to-face interaction.
Yeah, must be challenging.
Yeah, but for trainings, it really works.
Cool.
When you have something that is hands-on, it's fine.
All right. And then my final question is, do you happen to have a question for the audience?
Actually, I do, but
Awesome.
I'm afraid I might have answered that. But I'm gonna go ahead.
You might want to take a peek at the chat in Teams.
Yeah. So, when would be a good scenario to use gRPC?
That's your question.
Yeah.
All right. So I think that's it for now, Irina. Thank you so much for being at 4.Net Conf. You were really an awesome speaker, and I think that the content of your session was awesome. I learned a lot, and I'm definitely going into gRPC as of now.
Thank you very much for having me. It was a pleasure.
Cool. All right, and
I'll be around.
Yeah, thank you.